How's it going, Accelerated Chemistry? This is Mr. Spurk, and this is your Chapter 16, Section 3 notes on colligative properties of solutions. A colligative property is a property of solutions that depends only upon the number of solute particles, not upon their identity. Three important colligative properties of solutions are the vapor pressure lowering, freezing point depression, and boiling point elevation. Vapor pressure is the pressure exerted by a vapor that is in dynamic equilibrium with its liquid in a closed system, which we've talked about this before. A solution that contains a solute that is non-volatile, which means that it's not easily evaporated, always has a lower vapor pressure than the pure solvent. So with vapor pressure lowering, we have these two diagrams here. So let's look at the one on the left. Equilibrium is first established between the liquid and the vapor in a pure solvent. You see we have some of those gas particles above the liquid bouncing around, exerting vapor pressure. And then here on the right-hand side, in a solution, solute particles reduce the number of solvent particles. The solute particles reduce the number of solvent particles able to escape the liquid. So whatever we're dissolving in there is inhibiting the solvent particles from escaping. And equilibrium is established at a lower vapor pressure because there's less particles to exert a vapor pressure. Ionic solutes that dissociate have greater effects on vapor pressure than does a non-dissociating solute. 3 moles of sodium chloride dissolves in water to produce 6 moles of particles because each formula unit of NaCl dissociates into 2 ions. So that balance equation, if we have 3 moles of NaCl, that breaks up into 3 Na plus ions and 3 moles of Cl minus ions. And 3 moles of glucose dissolved in water produces 3 moles of particles because glucose does not dissociate. So the more particles that have dissociated, the lower the vapor pressure. Freezing point depression. When a substance freezes, the particles of the solid take on an orderly pattern. The presence of a solute in water disrupts the formation of this pattern, and as a result, more kinetic energy must be withdrawn from a solution than from the pure solvent to cause the solution to solidify. Think about, we talked so much about hydrogen bonding and that hexagonal structure of ice. So that those H2O molecules, they really have to slow down enough so that they can hydrogen bond to one another into their crystal. But when there's a solute particle involved, they get in the way and they disrupt that freezing. So this occurs at a lower temperature. The freezing point of a solution is lower than the freezing point of a pure solvent. The difference in temperature between the freezing point of a solution and the freezing point of the pure solvent is called the freezing point depression. The magnitude of the freezing point depression is proportional to the number of solute particles dissolved in the solvent and does not depend upon their identity. The freezing point depression of aqueous solution plays an important role in helping keep travelers safe in the cold, icy weather, and we know all about this living in central Ohio. The truck spreads a layer of salt on the icy road to make the ice melt. The melted ice forms a solution with a lower freezing point than that of pure water, and that way the roads will just be more damp than they would be icy. So we have freezing point depression, and we also have boiling point elevation. The boiling point of a substance is the temperature at which the vapor pressure of the liquid phase equals the atmospheric pressure. Adding a non-volatile solute to a liquid solvent decreases the vapor pressure of the solvent. Because of the decrease in the vapor pressure, additional kinetic energy must be added to raise the vapor pressure of the liquid phase of the solution to the atmospheric pressure that will initiate the boiling. The boiling point of a solution is higher than the boiling point of the pure solvent. The difference in temperature between the boiling point of a solution and the boiling point of the pure solvent is the boiling point elevation. Antifreeze, which we put in our vehicles, doesn't just lower the freezing point of the water in the cooling system, it also elevates the boiling point, which helps protect the engine from overheating in the summer. Boiling point elevation is a colligative property. It depends on the concentration of particles, not on their identity. The magnitude of the boiling point elevation is proportional to the number of solute particles dissolved in the solvent. Alright, so in review, colligative properties of solutions include vapor pressure lowering, freezing point depression, and boiling point elevation. As always, all the information on these slides has been acquired and adapted from Pearson Chemistry, 2012 edition of the textbook, the resources CD, and pearsonchemistry.com. Have a great rest of your day.